today we will deal with another peripheral known as ADC. So why you are using the ADC? Any idea? So whenever you want to connect sensors which are giving analog output, you need to use this peripheral in order to convert it into digital format. Because your controller is a digital device, so it can process only digital data. So that is the use of ADC. So in this LPC2148, we are having 10-bit ADC. What do you mean by that 10-bit? It is the resolution of ADC. In terms of voltage, resolution means it is a minimum possible voltage level it can convert to digital. In terms of bits, you are telling like this 10-bit ADC. That means when a particular analog voltage is converted into digital data, it will be having 10 bits in that way. So if we are giving a particular input analog voltage, ADC will be converting it into digital data. That will be having that can have maximum 10 bits. Right. So total how many levels you can have using 10 bits? 2 raised to 10. 2 raised to 10 combinations. That many levels. Or what is the maximum amount of maximum value of voltage it can convert to digital? Or what is a V reference plus and minus? 3.3. So because it can convert only voltages up to its VCC, so it is 3.3. So the actual resolution in terms of voltage will be 3.3 divided by 2 raised to 10. That is the minimum possible voltage level it can measure. And all the quantization levels will be in multiples of this voltage, 3.3 by 2 raised to 10. That many millivolts. So in terms of bits, the resolution of ADC is maximum 10 bit. Then it is having 6 channel ADC. So what do you mean by channel? It is a number of sensors or it is a number of input pins it can have for the ADC. It is having maximum 6 channel. That means 6 input sensors you can connect. 6 channels are there. So you can connect maximum 6 sensors. But one thing you need to keep in mind, 6 inputs are there, but only one ADC is there. So all the 6 inputs are connected to one ADC. So at a time, only one channel can be converted into digital. Even though you are connecting 10 channels, 6 channels, at a time only one channel will be connected to the ADC. Right? So here in this controller, you are having two set of ADCs. That is ADC 0 and ADC 1. Each ADC will be having 6 channels generally. And the channels are referred like this. For ADC 0, it is referred like this. AD 0.1 to AD 0.4. So 4 channels. Then AD 0.6 and AD 0.7. So total 6 channels are there. AD 0.5 is not available. So these are the 6 channels available in ADC. And you can see these are the 6 channels. It is shown in this red color. Here you can see P0.25 bar AD 0.4. P0.30 bar AD 0.3. That means it can be configured as general purpose P0.30 or ADC channel. So now you are going to configure the ADC in such a way that I am going to connect a sensor to channel 3 of ADC. So which is the simplest sensor you can think of? Potentiometer. All of you have seen the potentiometer in the say volume controls and other knobs are available in the amplifier, etc. or dimmer, etc. Have you seen that potentiometer? When you are turning that potentiometer knob, output voltage will change. So I am going to connect the variable point of potentiometer to analog channel 3 and the corresponding 10-bit digital data I need to display on one port. Say it may be port 1 or port 0. So each 10-bit data will be displayed on 10 LEDs connected to one of the port. I need to convert the digital data, convert the analog voltage into digital data. that corresponding 10-bit value, I need to display it on 10 LEDs. So these are steps. So first step is this, as you have seen in UART. First step is you need to configure P0.30 as analog channel 3, AD0.3. That is the first step. By default, all the pins will be configured as GPIO. Now I need to configure P0.30 as analog channel 3. So since it is P0.30, which register you need to select for configuring the functionality? Pin cell 1, because pin cell 1 is used for configuring pins from P0.16 to 31. So I am using pin cell 1. So this is a part of pin cell register. In this, which bit I need to configure for configuring P0.30? Bit number 29 and 28. So in pin select register, if you are configuring 29 and 28, you can configure P0.30 as any one of this value function. So I need to configure P0.30 as ADC channel 3. So what value should I write? 0, 1. So 0, 1 should be written to bit number 29 and 28. That means I need to clear bit number 29. I need to set bit number 28. Will you clear a bit? Let us take one example. This is one example. I need to clear these 2 bits. So what should I do? I need to clear these 2 bits. So what should I do? If I want to clear these 2 bits, bit number 2 and bit number 0, I need to AND with those 2 bits alone as 0, all the other bits as 1. What will happen? That corresponding bits alone will be 0. All the other bits will be as it is. Similarly, how will you set a bit? Say for example, I need to set this bit, first bit. So what will I do? I need to OR with that bit alone as 1, all the other bits as 0. So you can see that bit alone will be set. In this case, I need to clear bit number 29. I need to set bit number 28. So how will I clear bit number 29? I need to AND with bit number 29 as 0. Right, this is bit number 29. 29 as 0, all the other bits as 1. So what is this value? 1101 means it is D, and all the other values FFs. So you need to write pin cell and equal to. And equal to means pin cell 1 equal to pin cell 1 and this. That is known as and equal to. And equal to DFFF. So you are clearing bit number 29. Similarly, you need to set bit number 28. This is bit number 28. So how will you set it? You need to use OR equal to, what is this 0001? It is 1 and all zeros. OR equal to only that bit number 28 as 1, all the other bits as 0. So pin cell 1 OR equal to 0x1000. Okay. So that bit alone will be set. So here you are clearing bit number 29, setting bit number 28 for configuring P0.30 as ADC channel 3. In the next step, you are enabling the power or clock to ADC. That means you are enabling the ADC. You are enabling power or clock. For that, you are using a SFR known as P-Con-P register, power control for peripherals register. This is a register. So in this register, which bit you need to configure? Bit number 12. Bit number 12. So each bits are used for enabling certain peripherals. Here in my case, bit number 12 is used for enabling the power or clock to ADC. So how will you do that? P-Con-P or equal to 1 left shifted by 2. P-Con-P or equal to 1 left shifted by 12. So 12th bit alone will be set. You are using or equal to. You are not using directly equal to or equal to. That means only the 12th bit will be set. All the other bits will be as it is. Then in the step 3, you are selecting the channel. In the first step, you have configured the functionality. In this step, you are actually configuring the channel. So here, I need to configure channel 3 as the input. Right? So from this step onwards, you are using another important register of ADC known as ADC control register. So AD0CR, AD0, ADC0 control register. That is AD0CR. So in that register, bit number 0 to 7 is used for selecting the ADC channel 0 to 7. So wherever you are connecting your sensor, in my case I am connecting to channel 3, so I need to configure channel 3 here. How will you configure channel 3? These bits should be written with 4 zeros, 1 and 3 zeros. That is nothing but 8. So I am writing AD0CR or equal to 0008. If I want to configure it as channel 7, what modification I need to make? 80. Because 100000. That means it is 80. Previously it was 08. Now it will be 80. Data sheet, it is for ADC21 series. So
Okay.
whichever controller you are taking, that series you need to refer. This data sheet for, it is for 21 series, 214X series. When you are taking 2148, you will be having only 6 channels. 8 channels will not be there, only 6 channels. Then the next step, you are configuring the ADC clock. So ADC clock means it is used for configuring the speed at which or the rate at which you are going to perform the ADC conversion. For configuring that, you are using the next 8 bits, 8 to 15 of the same ADC control register. And you can have only these settings available. As you have seen in other peripherals, ADC is also connected to VPP bus. So for ADC also, you should take only P clock, not C clock. So here the ADC clock rate will be something like this: P clock by 1 to P clock by 8. So in my case, I am going to configure it as P clock by 8. So what value should I write here? 07. But you should keep in mind this 07 is from bit number 8 to 15. Right. So you should write 07 then 00 because initial 8 bits will be there. These are the next 8 bits. So you should write 0700. You should keep in mind it is or equal to. Why you are giving or equal to? Whatever value I am updating, only those bits will be affected. All the other bits will be intact. So here you are configuring the clock rate, ADC clock. In this step, you are configuring the burst mode of operation. For time being, you are disabling the burst mode. You are making bit number 16 as 0 or you are clearing bit number 16 as 0. How will you clear a bit? And equal to bit number 16 alone 0. So that is why FFFE is there. FFFE again 4Fs. So E stands for 1110. So that 0 will be nothing but bit number 16. So when you are performing AND equal to 3F, then E and 4Fs, you are clearing the 16th bit. In the next step, you are actually configuring the resolution of ADC. So I told you can have maximum 10-bit resolution. Maximum 10-bit resolution. And for converting each bit, it will take 1 clock cycle. And the additional clock cycle will be for updating the result into ADC result register, global data register. So if you are using 10-bit resolution, 11 clock cycles it will take. Right. So this is how you you are configuring the resolution. Bit number 17, 18 and 19. 19 to 17. So in my case, I am going to configure it as 11 clock cycles and 10 bits resolution. That is 10-bit resolution. So for 10-bit resolution, what you should write? You need to write 0000 to bit number 19, 18 and 17. That means these 3 bits you are clearing. 17, 18 and 19. So what you will do? FFF 1 FFF. That means bit number 19, 18 and 17 will be zeros. Only bit number 16 will be 1. All the other bits will be, all the 3 bits will be zeros. And again, you are not using direct equal to, you are using AND equal to. That means only those 3 bits will be cleared, other bits will be as it is. And then in the next step, you are activating the ADC. I think in the second step, you have enabled the clock or power. You have connected the clock or power. Now in this step, you are actually activating the ADC. How will you do that? Again, the same control register you are using. In that bit number 21 you will be using. 21 is nothing but power down bit for ADC. So if you want to activate it, what value you should write here? Bit number 21, what value you should write? Make it as 1. So again, you should use or equal to 21st bit alone as 1. That is 0, 0, 2, 0, 0, 0. 2 means it is 0, 0, 1, 0. That 1 will be 21st bit. Then in the next step, you are going to start the ADC conversion. So there are several options for starting the ADC conversion. Whether you can start the conversion now or you can start the conversion based on some signals on some of the other pins, capture pin, match control pins, etc. Right. For time being, you are going to start the conversion now. So bit number 26 to 24 will be used for doing that. What value you need to write? 001. When you are writing 001 to bit number 26 to 24, you will be starting the conversion. That means you need to set only bit number 24. Other bits will be 0. So you are giving or equal to 0, 1, 0, 0, 0. So here 1 means it is bit number 24. Now you need to wait until conversion is over. Right. You need to wait until ADC conversion is over. How will you do that? For that, you are having a register known as AD0 Global Data Register. AD0 Global Data Register. In this, bit number 31 is used for checking whether the ADC conversion is over. If this bit is 1, you can identify that ADC conversion is over. So how will you check that? You need to split this bit alone and you need to mask all the other bits. So what operation you should use? You need to AND with this bit alone as 1, all the other bits as zeros. You need to AND with this bit alone as 1, all the other zeros. That means AD0 GDR and 0x 8000. That means 31st bit will be 1, all the other bits will be zeros. That value you are checking whether it is equal to 0. If it is equal to 0, that means done bit is 0. So what you should do? You need to wait there itself. So in polling method, you will be waiting until ADC conversion is over. When it is over, what will happen? Done bit will be 1. So this condition will be false. And you will go to the next step. What will be the next step? Read the data from ADC data register, or you can use the global data register itself. Both are same, right? So here I am using ADC data register 3 because you are using ADC channel 3. So here again 31 bit will be the done bit, and here which bit, where will be your result available? Result 10 bit result will be available from bit number 15 to 6. So how will you actually read this bit? How will you actually get this data? It is coming in almost in somewhere in the middle. No? So how will you read this data? First of all, you need to right shift this data towards right. You need to shift the data towards right by how many units? 6 units. Then you need to mask all the other bits. How will you mask all the other bits? And with what value? Last 10 bit should be 1. That is nothing but 3FF. Because I need to read the 10 bits. All the other bits I need to clear it to 0. Right, because that is my value. And if in the previous step, if you are configuring the resolution as 8-bit, what modification I will make here in this statement? So you need to AND with 0000FF, because only 8 bits I need. But here I need to get 10 bits, so I am ANDing with 3FF. Right? So first you need to right shift by 6, then AND with 3FF. That value I am reading to a variable known as val. So you will be getting the value in val register. As the last step, you can deactivate the ADC. How will you deactivate the ADC? Same bit number 26 to 24. You can write zeros. 0, 0, 0. No start. So these are the steps. So if you want to continuously convert the channel 3, which all statement should be in while 1? I need to continuously read the channel 3. I need to display the corresponding value in what is that port 0. So which all statement should be executed. So your statements 8, 9, 10 and 11. All the 4 while 1. Deactivating means you are writing 0, 0, 0 to these bits. Here you are again writing 0, 0, 1. No? So it will start. This power down bit. Activation means it is power down bit. But for deactivating, I am using the type of start only. I am making these 3 bits as 0. Here I am making it as 1. So it will start. Then open your key. Save it as ADC. Here I am going to send my ADC value to port 1. So here in the program you can see AD0 CR equal to 0x20070. That means all the configuration I am doing in single statement except the channel. Right? Then here in this statement I am setting the channel as channel 3. Right? Then in this statement I am starting the ADC conversion. I am writing 0012 bit number 26, 25 and 24. Right? Here I am waiting for end of conversion till done bit is 1. When the done bit is 1, you are right shifting the data present in AD0 GDR by 6 ANDing with 3FF, right? So my ADC data is available here, 10 bit. That data I am going to send it to port 1, right? So how will I send that? I need to perform left shift by 16. Why? Because in port 1, your pins are only available from 16 to 31. So when you are writing to IO pin 1 register, you need to send the 10-bit value from 16th bit onwards. Don't write it directly. If you are writing it directly to pin 1, IO pin 1, what will happen? It will be going to P1.0 to 9. But you don't have any pins there. You are having P1.16 to 31. That is why you are left shifting by 16 and giving to IO pin 1. Then finally you are deactivating the ADC. You are giving some delay. In order to give this delay, I have told you to add your delay file also into your project directory. So copy your delay.h, paste your delay.h in your project directory. That is why here I have given double quotes. Why I have given this double quotes delay.h? Here I have given only less than and greater than. Here why I have given double quotes?
Check in the file directory.
Double quote shows your current working directory. You need to check in the current working directory. This Less than greater than means go and search in the compiler's system directory. Wherever H file is there, go and check there. Then in the ADC init, I am configuring P0.30 as ADC channel 3 and I am controlling the power. And before writing the value to IO pin 1, you need to configure the direction of IO pin as output and you need to configure port 1 as GPIO. These two statements also you need to write. Why? Because I didn't add the program. I need to add the program, then give build.